All right, everyone, this is a review for your exam. There will be a non-calculator portion and then a calculator portion. So hopefully with this portion you did not use a calculator. I have the chart already completed for you. A few things I want you to remember. When you have to a 0 power, or 0 is your exponent, it's a 1. When you have positive integers, which I have here, remember, my exponent is how many zeros I have. So if my exponent is 5, I have 5 zeros. This only works for powers of 10. Up top here, remember we learned in our previous unit, when you have a negative exponent, you change its location. When you change its location, the exponent becomes positive. That's why I put 10 to the third in the denominator. There's nothing in the numerator, so I put 1. This would become 1 over 1,000, which as a decimal would be 0.001 because you have the tenths, hundredths, thousandths place. And if I wrote 10 to the negative second as a decimal, I would have 0.01 because it's in the hundredths place. And 10 to the negative first, I would just have 0.1 because that is in the tenths place. So get a good picture of this and make sure you memorize this for your exam. On this next part, it's asking me to estimate to the nearest power of 10. So you could refer to your table to figure out which power of 10 that my answers or my questions would be closest to. So 5,345. If I look at my powers of 10 table, is 5,000 closer to 1,000 or 10,000? Well, remember, if we go 5 or above, you round up. So I would have that 5,345 is closer to 10,000. And when I write that as a power of 10, because that is your final step, it would be 10 to the fourth power because I have 1, 2, 3, 4 zeros. Next one, 67,452. That one would be closer to 100,000, which is the same as 10 to the fifth power because I have 5 zeros. 205 is really close to 100. That would be written as 10 to the second power because of the 2 zeros. And 56,700,000 is going to be closer to 100 million as opposed to 10 million. So 100 million would be rewritten as 10 to the 8th power because I have 8 zeros. Please remember on your test, if I'm making you estimate to the nearest power of 10, you just include your powers of 10. So these would be my answers on my test. Feel free to write in this information to help you, though. When you get to the next question, however, let me scroll to my next page. It's asking you to estimate as a single digit times a power of 10. So, think about this. Would I estimate 5,345 closer to 5,000 or 6,000? In this case, it's closer to 5,000. Then to express that, my single digit is a 5. So I have 5 times 10, and I have 3 zeros. That's why it's to the third power. 67,452 is closer to 70,000 than 60,000. My single digit is a 7 times 10, and I have 4 zeros there. 379 is closer to 400 than 300. My single digit is 4 times 10, and I have 2 zeros, so it's to the second power. 56,700,000. I round up to 60 million. 6 is my single digit, times 10, and I have 7 zeros. And lastly, 4,500,000. I would definitely round up to 5 million. This is a 5, by the way. My single digit is 5 times 10, and I have 6 zeros. Remember, when you are estimating or rounding, if the number that you are rounding is 5 or more, you round up. If not, you just leave it the same. Remember, scientific notation is a single digit. So you have a number here. It's always times 10 to a certain power. This value out in front has to be greater than or equal to 1, but less than 10. And remember, this right here is how many times your decimal point would be moving. So my first step is to figure out where my decimal would go so the number out in front is greater than or equal to 1, but less than 10. So I'm going to put it in between, it's hard to do on the screen, in between the 6 and the 7. So I would have 6.7, because that's between 1 and 10. Then I would do times 10. Then I have to count however many times I moved it, or think about how many digits are after your decimal. 1, 2, 3, 4, 5 times. So 6.7 times 10 to the 5th power. Next one, my decimal would go between the 4 and the 5. So I would have 4.509, always times 10. And then I'm going to start to cross off and count every single digit that is after my decimal. 1, 2, 3, 4, 5, 6, 7. So it's to the 7th power. 53,000, I'd put it between the 5 and the 3. So I have 5.3 times 10. And if I start to cross off and count, I would have 1, 2, 3, 4. Now this next one's a little different. It's a decimal. It's a number that is less than 1. So there's one only trick to it. First step is the same. Make sure you put your decimal point so your value would be between 1 and 10. So I would do 4.83 times 10. And in order to count this time, you count in between your decimal points, however many digits are between there. So I have 1, 2, 3, 4, 5, 6. But remember, if your number is less than 1 to begin with, your exponent is not positive, it is negative. Next one between the 9 and the 8, so I would have 9.8 times 10. If I cross off and count, 1, 2, 3, 4, 5. But since my number is less than 1 to begin with, I have a negative 5. And these colors I'm just throwing at you have nothing to do. I'm just changing my color. I would put my decimal between those two 4s. So I would have 4.44 times 10. Count your digits in between your decimals. So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9 though, because my value was less than 1 to begin with. Next one, I would put it between the 2 and the 4, so I would have 2.45687 times 10, and count however many digits are between your decimals. So I would have 1, 2, 3, 4, and it's positive this time because your value to begin with was greater than 1. And lastly, I would put it between the 4 and the 7, so I have 4.722678 times 10. Count how many digits are between your decimals. I have 1, 2, 3, so it's to the 3rd power. Make sure you can do this. This is definitely on the non-calculator portion of the test. Remember, if your value is bigger than 1, your exponent is positive. If your value was less than 1 to begin with, your exponent is negative. And remember, do not just count the zeros when you are doing scientific notation. You must count every single digit, or however many times you move your decimal point. All right, now we are writing in standard notation. So think, if you have I'll just write it off to the side, a positive exponent, you move to the right. If I would have a negative exponent, I move to the left. So for this first one, I do have a positive exponent. I need to move it to the right 6 times because of my exponent of 6. So starting at your decimal point, move to the right 6 times. So I have 1, 2, 3, 4, 5, 6. So my answer would be 5405 with your 3 zeros. and make sure your final answer on your test, you include your commas. So this would be 5,405,000. Next one. It's also positive, so I'm going to move to the right 7 times. So if I start counting 1, 2, 3, 4, 5, 6, 7, if I rewrite that value, I would have 4, 3, 4, and then your 5 zeros, just basically rewriting what I had here, and then add your commas. The next one is negative, so I'm not moving to the right this time, I'm going to move to the left. So I already have 1 digit to the left, so I have 1, 2, 3, 4, 5. So my answer would be point with your 4 zeros, and then 5, 0, 0, 1. Another one, I am moving to the left because my exponent is negative, so let's cross off and count, moving 7 to the left. So I have 1, 2, 3, 4, 5, 6, 7. So make sure you put your decimal point with your 6 zeros this time, and then your 8 and your 9. This time it is positive, so we're moving to the right 8 times. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm just going to rewrite that value. Include your 4 zeros that you had to add on, and then make sure to put your commas there. The next one is negative, so I'm moving to the left 5 times. 1, 2, 3, 4, 5. Decimal point with your 4 zeros, then 2, 2, 0. The next one is positive, so I'm moving to the right 5 times. 1, 2, 3, 4, 5. So rewrite your original value and include your zeros. In this case, I only had 2. So my answer would be 999,900. Now this time my exponent is positive, but it's only 1. So I'm just going to move to the right once, and that's where my decimal point would go after. So my new answer would be 67.224. Remember this next one, anything to the 0 power is just, this would be considered 1. So you just have that original value. So I have 7.98554. Like I said, you just rewrite that original value. And this last one is negative, so I move to the left once. I don't have to do anything else other than put my decimal point there. So I would have 0.37224. This is the big concept to remember when you're converting from scientific to standard. Make sure positive exponent you move to the right, negative exponent you move to the left. Start crossing off your digits and then add however many other zeros are necessary to make it match your exponent. Hopefully comparing the following numbers weren't that difficult. It says to circle the value that is larger. So for part A, I knew that the very first one is larger because the larger the exponent, the larger the value. So since my exponent was 5, that's why this is larger. The next one, look at your exponents always first. So 10 to the 8th is larger than 10 to the 4th. That's why this will be larger. And looking at part C, this one would be larger because if you compare your exponents, 9 is larger than 3. Always compare your exponents first. If your exponents are the same, then try to look at the value out in front. So for example, if I would have given you 2 times 10 to the 4th, and let's say 1 times, let's say 10 to the 4th. My exponents are the same here, so therefore right now I need to look at the value out in front. 2 is larger than 1, so this would be larger than this one. All right, we're going to turn the following into scientific notation. So 725 is not between 1 and 10. I would have to move my decimal in between the 7 and the 2. So this would become 7.2514 times 10. Think about however many times you moved it in between that decimal. I moved it twice, so I'm going to have to add 2 more to that exponent. Since it was a positive, it was a larger value, so it would be 10 to the 7th power. This next one, I would have to put my decimal point between the 7 and the 6, so I would have 7.65 times 10. I had to move it 2 times, but since my number was smaller to begin with, it was a less than 1, I'm going to subtract however many times I moved it to give me 10 to the 6th power. 657, my decimal would go between the 6 and the 5, so 6.57 times 10, and I had to move it 2 times. Since my value to begin with was greater than 1, I'm going to add that distance to it, so -4 plus 2 gives you a -2. Okay, make sure on this next part on your test you estimate each value and then express it as a single digit times the power of 10. So, key things here. In this question, the first thing I would do is estimate each value. So 1700, I would round to 2000. 22,300 is closer to 20,000 than 30,000. Then I would express them as a single digit times the power of 10. So this one would become 2 times 10 to the 3rd. And down here, this would become 2 times 10 to the 4th. The question states how many times larger. Anytime it does that, you must always divide. That's a buzz phrase to know division. Remember, take whatever it states first in the question. So it says Mavericks Mud Bog, so I would put that in my numerator since that was stated first, compared to Diesel's Doggy Park, so I would put that in my denominator since that was stated second. Remember, rules for dividing: divide your values out front. 2 divided by 2 is 1 times 10, and when we are dividing, we subtract our exponents. 4 minus 3 is 1. So this is the same as 1 times 10 to the 1st, or just 10 times larger. Next question, we are going to do the same thing. So Cash has a swimming pool that has a length, gives us the length and the width. So let's first estimate. 10,200. If I'm estimating that, it would be closer to 10,000. And if I express this as my single digit, which is 1, times 10 to the 4th power, then my width, 272,454. I would round that to 300,000 because it's closer to 300,000 than 200,000. Expressing this, my single digit is my 3 times 10, and I have 1, 2, 3, 4, 5 zeros. Anytime the question asks you to find the area, think, what's the area of a rectangle? What's the area? I always multiply my length and my width. So I'm going to do 1 times 10 to the 4th times 3 times 10 to the 5th. Remember our rules. We can multiply our values out in front. 1 times 3 is 3 times 10. And remember, when we're multiplying, we really add our exponents. 4 plus 5 would give you 9. So 3 times 10 to the 9th power is my answer. So that's all we have to review for our non-calculator portion. So from here on out, yes, use a calculator. Do not make silly mistakes. make sure your calculator is always in SCI mode. That's crucial for your success. Alright, so for questions A through D, and honestly for this entire page, if you are actually the next two pages, if you are permitted to use a calculator on these problems, use a calculator. Do not try to do them by hand. The only thing I would stress, and no, you don't have to use parentheses for every case, but I tell kids to make sure to put their parentheses in because it will make sure they get the correct answer. And so this first answer would be 3.497904 times 10 to the 11th. So like I said, key points on this entire page. Make sure you put parentheses around if you are not getting the answers that I have on here. You need to ask me, ask someone around you, and I would double, triple check on this part of your test because you could make the smallest error that would give you the wrong answer just by putting in a number wrong. So make sure to double and triple check your answers on this part. Also, make sure that your final answers are always in scientific notation. So double and triple check that your calculator is always in SCI mode on this part of the exam. Now we are getting into your favorite, the word problems. So first, like we did when we were estimating, make sure your answers are expressed, in this case, in scientific notation, which in this case they are. Also look at the question. This question states how many times larger. Remember, when it says how many times greater, how many times larger, you must always divide. Look to see what it stated first. It has the thickness of the construction paper, so that is what's going to be in my numerator. So I have 4 times 10 to the negative 5th, and divide it by the computer paper, which is 4 times 10 to the negative 6th. You can use your calculator for this one, which you would get 1 times 10 to the first power, which is just 10 times. So look for those key words or phrases to let you know what operation to do, and make sure whatever is stated first in the question part goes in your numerator, whatever is stated second goes in your denominator. Next one. Both of my values are in scientific notation, and the question states how many times as great. Once again, we are going to divide. So it has Lake Cassie. The number of gallons of water in Lake Cassie is how many times as great, or Lake Hauser compared to Lake Cassie. So since it has Lake Hauser stated first, you're going to put that in your numerator, so 3 times 10 to the 14th, and divide it by 4 times 10 to the 6th. Use your calculator, and you would get 7.5 times 10 to the 7th power. Your final answers must be written in scientific notation. Next question. During the school year, talks about students planting trees as a service project, and it gives how many students. So I want to know how many trees did they plant in total. Well, if I know how many students there are and how many each student planted, I am going to multiply. So I'm going to take 2 times 10 squared and multiply it by 3.5 times 10 to the 3rd power. When I do that, I would get 7 times 10 to the 5th. If you put 7.0 times 10 to the 5th, same thing. Next one, the question states what is the difference? When you see the word difference, know to subtract. So I'm going to first make sure to convert each of these into scientific notation. So this one I'll slide over here would be 2.7 times 10, and I moved my decimal 1, 2, 3, 4, 5, 6 times. this one up here would be 1.8 times 10, and I move my decimal 1, 2, 3, 4, 5, 6 times. So if I want to know the difference between them, I would subtract 2.7 times 10 to the 6th minus 1.8 times 10 to the 6th. And my final answer would be 9 times 10 to the 5th. Like I said, when you are doing these, make sure you put parentheses around them so you are getting the same answer, the correct answer that you should. Lastly, we talk about Rupert's Renegades, and I want to know how many total golf balls will both companies produce. I want to know the total between two companies, so I'm going to add them. So Catay's, if I would put that into scientific notation, I would have, make sure to put in parentheses, 8.3274 times 10, and I moved it 1, 2, 3, 4, 5, 6. And I'm going to add it to Catay's Crushers, which would be 1.134 times 10, and I moved it 1, 2, 3, 4, 5, 6, 7 times. If I add those together and make sure I use my parentheses, my final answer would be 1.96674. I'm running out of room, so I'm going to write it underneath, times 10 to the 7th power. So the big thing you have to remember about using the calculator, make sure you're in scientific mode, SCI mode, and also make sure you are using parentheses. No matter if you see them or here I didn't put them, still make sure you put them in your calculator. So please study, study, study. If you have questions, email us, ask peers. We want to make sure you do your best on both parts of this test, the calculator portion and the non-calculator portion. Make sure that you remember that the non-calculator portion is first. And I hope this helped you out a little bit. Thank you so much and have a wonderful day.